You know which one I really like too? I just remembering is there's an image where you kind of wearing a dendrite, like a crown.
Oh yeah,
that was really cool.
Yeah.
Step aside for the dendrite queen.
Yeah, that's it.
Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
All right, welcome back to SMTA International here in Rosemont, Illinois. We're in the Decode Podcast booth, and we're joined by Miss Viktoria
Rawinsky.
I wanted to roll the R though.
Rawinsky.
Thanks for joining us. We kind of became familiar with you fairly recently. You've been doing a fantastic job of posting consistently on LinkedIn. Some really cool content, and it shows that you're passionate about what you do, and the way that you frame the work you do is almost like it's a murder mystery.
Yeah.
Right. It's this detective work.
How did this PCB die? Who's the fault? Who's at cause?
Yes, I love storytelling and also story listening and story reading.
Mm-hmm.
Yeah, it's fantastic. It's like riveting, and I'm like waiting for the next one. It's been very good to see. So tell us a little bit about the crime solving that you do.
I usually use FDR spectroscopy for detective work. The largest FDR spectroscope available on the market, so I'm able to see very, very deep up to the last molecule inside the material and find the root cause of product failure, even after product recall, after the disaster has already happened.
So you can go to the scene of the crime and figure out who did what.
Yes.
And not involved. Just electrochemical migration stuff on top of the surface, but way deeper than that, and like CAF and other issues that are internal inside the board.
From my experience, the root cause is very, very small. It's the very beginning of the manufacturing process of the PCB itself. But the disaster is great afterwards if the problem is overlooked or ignored.
I know one of the things you've talked about quite a bit is it uncured solder mask or solder mask that is beyond where it was meant to go, and now it's like creeping over pads when it's not supposed to, and getting in areas of the board that it wasn't actually designed to be. How do you think that happens? Why is that so common?
There are many different ways which can lead to the solder mask spreading all over the PCB surface. One of them is incompletely cross-linked solder masks. That means you have long molecular chains in the solder mask itself, acrylate chains, and they link just together by cross-linker to a three-dimensional network. If what the manufacturer of the PCBs usually used to do is to shorten the cross-linking time by giving cross-linker in excess. So they're still present, but I have too much of them. But if I shorten this time, I cannot influence some chemical processes which needs time to react. Overflow is the more the better is not true.
Mm-hmm.
And if I shorten the time for cross-linking, I have a cross-linker on the one side, but incompleted reactions on the other side. And there's one step of the solder mask manufacturing process which is influenced by temperature, so it's a drying process. And there are some air blades blowing all of this away and heating the surface up. But if the PCB surface, the solder mask surface is not completely reacted. And for drying process and by blowing process, I just spread it all over the surface. And this is evil because the solder mask layer cross-linked, first cross-links on the solder pad, and you cannot remove it anymore. Very, very thin layer, just a couple of nanometers, less than micrometer. You cannot see it. And the PCB pass every electrical test. Why? Because the needle is coming down just push the thin layer away and you have great electrical results. You can print this PCB and it looks beautiful. You solder this PCB and then you say, oh my goodness, I have solder beads. Sometimes even solder powder, less than one micrometer small, and really ugly solder joints. And the customer usually used to brush it away and okay, look beautiful again. But the issue is that if the solder mask is not completely reacted, not completely finished, I have huge microscopic holes inside and also reactive partners. So chemical substances which just grab the humidity from the air and let it go underneath the solder mask.
So during, I did circuit board fabrication for 15 years of my life. Raised around it my whole life though.
Walking plate and deck since he was 4 years old.
Yeah, I walked plating decks with my dad, 5 years old. But so are you talking about the hardener they put in the actual ink as well when they mix it up? Or are you saying, okay, and they're not giving it enough agitation time?
There are a lot of steps. Another
That's the
point.
problem with PCB fab, right? Like there's so many steps during the process.
Yes.
And you really don't notice the failure until like Hazel pot dip, right? So I'm dipping in Hazel, I'm like, that looks really weird, or it's not even adhering to it. Then I know there's some type of contamination. Did it happen in plating? Did it happen in resist strip? Did it happen, right? Like the detective work that you talk about, it's so true. And what I noticed the most too is we actually had 2 valves on our tunnel oven for tack drive. One was for summer and one was for winter. The different humidity inside the building affected your solder mask cure 100%. And the same thing for final bake after solder mask. So during the summers, you had to go an extra 10 minutes in final bake. And then during the winters, you could dial it back to an hour. I mean, not the biggest deal in the world, but the way we did it was we had these timers on the wall, right? And there were 60-minute timers. So you'd go like this, right? Then you had to set another one for 10 minutes during the summer, right? So we liked the winter time because then we just 60 minutes and done, right? It was a huge difference between when you would go to do your dip it into your hotter solder level machines. You would notice it. It would be undercured. And then your mask would be, and there's no really going back. You can go back with like a solder mask stripping machine, but it's an awful process. It's not, it smells and it's got to be heated.
I believe, yes.
Yeah, it's not good, right? It's not, yeah. It's possible, but it's never going to perform the same way that it was before. And to your point too, like those pins on those probes, right? They can make an indention on the actual pad itself. So that thing will find a connection if it's air, right? And then usually when there's an error and the pads look good, you don't adjust again. You're going to hit the same spot. So maybe you nicked away that debris, right? And then you nick it away, but you didn't just nick. And there were needles, right? So the rest of that little section might now be good, but the rest of it is still contaminated, right? Yeah.
Right.
But it's weird. I do get a lot of messages from people, and they'll send me weird pictures of soldering that just looks awful. And I'll say, I don't know what's going on with that. But now, after you're talking about it, it makes more sense because I'm like, what contaminant could be on there that would survive? Because the circuit board fabrication process is brutal. It's a rough process from start to finish.
Harsh. Yeah.
Yeah, that thing is getting chemicals and acids and strips, and it's just getting hammered with water. Yeah,
and everything has to be very well balanced.
Yeah, I mean, think about like what organic can live in like a 300-degree lead-free Celsius pot, right? And get dipped in there for 7 seconds and then come back. It's got to be, and it's just amazing that anything can survive through that process, right? But it's interesting because I almost wish I had that, and because no department wanted to say that they were the root cause.
No, sure.
Right?
Right.
It will always happen at drilling, right? The first stage, right? Or shearing even before that, right? They sheared it differently, right? Like the angle was off or something like that. But I didn't even know an option like that existed to actually do detective work on to figure it out and let the science speak for itself. That's pretty cool.
It kind of blows my mind that you're saying it only takes at the nano scale can ruin everything. Well,
the equipment you use is fairly specialized, right? That has to be quite an investment, I would imagine.
Yes, investment in equipment and investment in knowledge. And investment in knowledge is more important thing. Because everyone can measure and analyze anything, but the skill of interpretation and reading the fingerprints, overlaid fingerprints, you have several substances which each of them has its own fingerprint, but if they overlay it, it's not very easy, but I love this kind of detective work, and I'm really happy when I found the small evil peak, and I exactly know, yes, got it. I know what happened.
Yeah.
So what's your average client? Like, do you work primarily with original equipment manufacturers or contract manufacturers or all the above?
As well as I work with PCB manufacturers. They just get some beautiful shiny green flat PCBs, printed, put components on top, run it through the soldering machine, and get some a really ugly result. So they cannot know what happened because the profile optimization is done. Everything seems to be okay, but the result is ugly. And from time to time, I have customers from the component side, because also the component can have problems. And I have one example from the LED manufacturer. He just told me he makes some panels for sauna, so event sauna with light and yes, some of these LEDs didn't work anymore, and she just asked me, the date code before worked very well, and the date code after also worked, but what's wrong with this one? And what happened is the material itself of the housing was a little bit too old, overaged, a little bit brittle. And what happened is, if the LED is getting hot by lighting, there are two parts of the housings which just sit like this, let humidity in, and then it happens.
Oh wow, that's at the component level.
I have a nice LinkedIn story where the light is also shadow about this.
Yes, I remember that one. You know which one I really like too? I'm just remembering is there's an image where you kind of wearing a dendrite, like a crown.
Oh yeah,
That was really
Yeah.
cool.
Step aside for the dendrite queen.
Yeah, that's it.
Nice. Nice. I like it.
I cannot talk directly about customers' cases because of the NDAs, like a holy Bible.
Sure.
But if I do that in a very creative way, like telling nightmares or crime stories, I can do that.
Yeah.
So it's obvious that you're doing what you should be doing. You love what you're doing. How did you find your way to that?
Oh, I studied or graduated in plastic and rubber engineering more than 20 years ago, and worked for 7 years for Fraunhofer Institute. It is the largest one in Europe, in research and development of new materials, smart materials, sensors and actors, and I loved this. After that, I switched to the electronics manufacturing area and worked for 10 years for Kurz, the other company. Also on the material science, but also on the process optimization for soldering processes. I have 2 patented technologies. One of them is voidless technology, so to reduce voids from the solder joint by influence of vibrations.
Okay.
And another one is for cleaning condensate residues from the soldering machines by inhibiting some cross-linking reactions, because condensate residue is also kind of plastic. Every part of the PCB outgas, also from solder paste, solder mask, also from the components, and then can react with each other in the solder machine atmosphere. They get all what they need: temperature, time, enough movement to connect with the right partners to create this dirty, evil layer of something which look like caramel.
It's the perfect environment for that to brew in, right?
Yes.
So at what point did you decide to take a jump and go in on your own, start your own business?
Yes, during Corona crisis was a good time to invest because the business was really weak and I could buy my research level spectroscope for reasonable money. I always wanted to do something on my own.
Yeah, so you instead of being afraid and not making investments, you saw that time as an opportunity to make the transition.
Yes.
And do you do much work in the States, or is it primarily in the European market?
Primarily in the European market, but I love the SMTA International and I love the stage. I get the largest stage on Tuesday.
Yeah.
Oh yeah.
Yeah.
Had a nice talk about between solder bead formation and product recall. And the stage was full of audience, so that's what I love. I love talking to the people. I love sharing my knowledge and just help people to understand the complexity of the electronics manufacturing and of the problem building. If people understand what can go wrong, they can react much faster and save a lot of money.
Have you ever had a criminal that escaped without being detected?
No.
No,
Yep.
You found them all.
you always find it.
Yes.
Wow.
But I'm sure it will be one day I can't.
I don't know. It doesn't sound like it.
But I learn every day a lot.
Yeah.
Well, we certainly appreciate you joining us.
Yeah.
Thank you for having me here.
We're big fans of your work, and we hope you'll keep it up because I know we enjoy it. And it's fun, but I always learn something like, oh, that's interesting. So fantastic job with that content. And yeah, really just a pleasure to have you on.
Thank you.
Thank you, Victoria.